In this video, we introduce our work LayerAnimate, layer-specific control for animation. Layer is a fundamental concept to animation, which allows the separate handling of backgrounds, characters, and special effects, preventing unintended alterations across elements. However, layer-specific data is scarce compared to real-world videos due to its commercial value. Therefore, we must first design a layer curation pipeline to extract layer data from animations. Here we present a clip from an animation as an example to introduce our layer curation pipeline. We employ SAM to segment the element masks in the first frame of the clip. Then these masks serve as prompts, which are then propagated to successive frames using SAM2, forming temporally continuous masklets. To address the over-segmentation issue, we introduce motion state hierarchical merging to merge these masklets based on their motion states, which are estimated by averaging optical flow across the temporal dimension. In motion state hierarchical merging, layers with similar motion scores are merged from the bottom up until the layer count falls below the capacity and the motion score difference exceeds the threshold. Finally, we obtain the curated layer masks of the animation clip. With the curated layers, we implement motion state allocation to separate dynamic and static layers to prepare layer guidance. We allocate the reference static layers to all non-reference frames. For dynamic layers, we allocate 0 images to those frames. Then the allocated layer regions are encoded with a VAE encoder, and we concatenate the resized layer masks to indicate valid condition areas. In the framework, we utilize layer-specific motion information to provide motion control. Here, we use scores as motion information. Not only that, sketches can also be utilized for this purpose, which is demonstrated in the latter part of the video. The layer latents and motion information are combined and fed into layer controlnet to guide the denoising unit. To demonstrate the versatility of LayerAnimate, we conduct comparisons across 4 video generation tasks under different conditions and within several representative scenes, including image to video to create particle effects, image to video with sketch for generating light effects, interpolation to make smoke appear out of nowhere, and interpolation with sketch to achieve a fade in visual style. LayerAnimate enhances fine-grained control over animation layers, offering many innovative and user-friendly control options. In the image-to-video task, if users wish certain elements in the image to remain unchanged, such as the boy, they can explicitly fix that layer to keep the boy stationary. With our layer-specific control, users are only required to provide partial sketches for dynamic layers without the need for conditions on static ones. Furthermore, the static background can be switched with different scenes, enabling dynamic layers to appear in user-desired backgrounds. For example, we can move the girl from inside the room to a picturesque setting among blossom trees. In interpolation with sketch task, LayerAnimate can interpolate the different backgrounds for smooth transitions while controlling foreground layers based on partial sketch guidance. Since layers are independently encoded within layer controlnet, our foreground layers are nearly unaffected by the background. Moreover, we present more qualitative results to demonstrate the effectiveness and versatility of LayerAnimate in animation quality. Thanks for watching.